Assalamualaikum and hi everyone. So in this video we are going to continue our lesson for chapter 5 states of matter. So we are going to study about 5.1 continue for gas. So these are the learning outcomes for this topic. So at the end of this topic, students should be able to explain the ideal and non-ideal behaviors of gases in terms of molecular, intermolecular forces and molecular volume. Okay, so kita akan terangkan tentang ideal dan juga non-ideal, sifat ideal dan juga non-ideal untuk gas. Then number 2, we are going to explain the conditions at which real gases approach the ideal behavior. And then these are the characteristics of ideal gas dan juga non-ideal, or kalau non-ideal we also known as real gas. So kita terbahagi kepada dua. So the first one is ideal gases and the next one is real gases. So untuk ideal gas, gases molecules are very small and have negligible volume. Okay, and then for real gases, the gas molecules have a certain volume. Then for ideal gases, the intermolecular forces between the molecules are negligible, and the real gases, there are weak attractive forces between gas molecules. So these are the two difference between ideal gas dan juga non-ideal gas. Okay, and then for real gas ataupun gas sahih, so it is approaching ideal behavior. Okay, all gases show ideal behavior at low pressure. Okay, the temperature is very low, and when the temperature is high. Okay, so when the low pressure and high temperature. So at low pressure, okay, at low pressure, the volume of container increases. So the gas molecules are far apart from each other, and then the intermolecular forces can be neglected. Okay, so kita boleh anggapkan bila dia jauh di antara satu sama lain. Okay, so this one dia far apart. Okay, di antara satu sama lain. Okay, far apart each other. Bila dia jauh, okay, intermolecular forces can be neglected. Okay, boleh kita abaikan. So the real gas behave ideally. So kalau kita boleh abaikan dia punya intermolecular forces, so you can say that real gas behave ideally. Then at high temperature, okay, kalau suhu yang tinggi, so you can see ke sini, okay, the gas molecule possesses high kinetic energy, and kinetic energy of the gas molecules can overcome the intermolecular forces. Jadi this kinetic energy boleh diatasi, okay, oleh intermolecular forces. So intermolecular forces can be neglected. Okay, thus real gas behave ideally at a high temperature. Okay, bila suhu yang tinggi, okay, dia akan bergerak pantas. Jadi dia as if tiada attractive forces between the intermolecular forces between the molecule. Jadi we can say that the real gas behave ideally. Next, okay, kita tengok van der Waals equation. So van der Waals equation, okay, kalau ideal gas equation, it is PV is equal to nRT, but for van der Waals equation, kita akan tambahkan n square A over V square times V minus NB. So this one, okay, ini adalah yang kita tambah lah, okay, kita tambah dan yang ini kita tolak. Okay, V minus NB, kalau P pula kita n square over V square, n square A over V square. Okay, so kalau P dengan V saja, dia tinggal PV is equal to nRT. So the ideal gas equation needs to be redesigned to describe the real gas behavior more accurately. Okay, so van der Waals adjust the ideal gas equation by correcting two parameters. Jadi dia akan membetulkan dua parameter, iaitu pressure. Okay, so pressure dia akan dari segi attractive forces between the gas molecules, manakala volume pula dia adalah volume of the gas molecules. So intermolecular forces between the molecules, okay, daya tarikan di antara molekul. So untuk ideal gas, okay, for ideal gas, intermolecular forces between the gas molecules are negligible. The more collision of gas molecules with the wall of container, thus higher pressure produced. Okay. Untuk real gas, okay, for a real gas, intermolecular forces exist between the gas molecule. Okay, kalau untuk real gas kita anggapkan ada daya tarikan di antara molekul. So less attraction, less collisions of gas molecule with the wall of the container. Jadi kurang, okay, kurang pelanggaran di antara molekul ini dengan dinding. Jadi low pressure produce. Okay, jadi kita akan ada suhu tekanan yang lebih rendah. Okay, so this one is higher pressure produce bila ideal gas. Kalau untuk real gas, low pressure. Okay, lower pressure. So since P real is lower than P ideal, okay, the term pressure need to be corrected by adding coefficient N square A over V square. Disebabkan kita nak betulkan pressure di dalam real gas, okay, dia akan corrected dengan menambah coefficient, okay, perkali N square A over V square. So P ideal is equal to P real plus N square A over V square. Okay, alright. So please note that N square A over V square dia merupakan correction untuk molecular attraction, di mana A adalah constant that indicates the strength of the intermolecular forces between the molecule, and the greater the value of A, the stronger the attraction. Okay, so the unit untuk A adalah atm liter square per mole square. Alright, so untuk volume gas, for volume gas, ideal gas, okay, untuk ideal gas, volume of gas molecules are negligible. Jadi V ideal equal to V container. Okay, so kita boleh katakan bahawa V ideal gas ini sama dengan V container. Okay, dan kalau untuk real gas, the gas molecules have certain volume. Jadi V real gas sama dengan V container plus V gas. Okay, right. Since V ideal is less than V real, so the term volume need to be corrected. Okay, jadi kita akan tolak menggunakan coefficient NB. So V real minus NB. So note that NB sama dengan correction untuk volume of molecules. Okay, where N merupakan number of moles of gas, B is a constant that indicates the actual volume occupied by the gas molecules. So the greater the value of B, semakin besar nilai B, the larger the molecules or the atoms. Okay, so the unit untuk B is liter per mole. Okay, so that's all untuk ideal gas and real gas. So now we proceed to 5.2 liquids. So these are the learning outcomes for the topic of liquids. At the end of this topic, students should be able to, first one, we are going to relate the properties of liquid to intermolecular forces, molecular arrangement, and molecular motion in explaining shape, volume, surface tension, viscosity, compressibility, and diffusion. Okay, we are also going to explain the vaporization and condensation process based on kinetic molecular theory and intermolecular forces. So C, we are going to define the vapor pressure and boiling point. D, we are going to explain the boiling process. So let us look into the first factor, affecting general properties of liquid. Okay, faktor yang mempengaruhi sifat umum bagi sesuatu cecair. So the first one is arrangement of particles. So di bawah susunan particles ini, susunan zarah, the liquid state is an intermediate between solid and gaseous state. Liquid ni sebenarnya dia di antara solid dan juga gas. Okay, in a liquid, the particles are very closely packed as compared to the gaseous state. Jadi dia sangat padat lah kalau kita bandingkan dengan gaseous state, because they in between. So the next one is intermolecular forces. Okay, factor yang kedua adalah daya antara molekul. The strength of the intermolecular forces between the molecules. Solid lebih kuat daripada liquid. Liquid is stronger than gas. So types of forces between molecules in liquid is van der Waals forces and hydrogen bonds. So next one kita tengok properties, okay, molecular arrangement. So kita ada states of matter, solid, liquid and gas. So solid, okay, molecules are very close together and neatly arranged. Jadi molekul ni dia akan rapat dan juga tersusun, okay, dia akan tersusun dengan kemas. And then liquid. For a liquid, molecules still very close, but not neatly arranged. And for gas, molecules are far apart from each other. Next, intermolecular forces. Okay, state of matter solid is the strongest. Solid mempunyai intermolecular forces dari antara molekul yang paling kuat. Okay, liquid weaker than solid, but the gas is the weakest among these three: solid, liquid, and gas. Next, molecular motion. So molecular motion, okay, molecules can vibrate but do not move from their position. Okay, sebab apa? Solid ni dia disusun dengan rapat. And for liquid, molecules are able to move around, but for gas, molecules are move very fast in all direction. Okay. Alright, so the next one, kita pergi kepada general properties of liquid. So it has a definite volume. Okay, isi padu yang tetap. The intermolecular forces is strong enough to keep the liquid molecules together. Okay, dia adalah cukup untuk memegang memegang molekul cecair. Okay. Jadi kalau dekat sini kita ada satu botol dan satu bekas kaca di sini. Okay. Dia akan ikut. Kalau 200 dalam botol, 200 juga lah di dalam bekas kaca tu. Okay, alright. So indefinite shape. The intermolecular forces is not strong enough to hold the molecules in fixed position. Okay, jadi maksudnya dia akan mengikut bentuk yang kita letak lah. Kalau kita letak dalam conical flask, dia akan shape of conical flask. Okay, for volumetric flask, dia akan follow the shape. And then for test tube, dia akan berbentuk test tube. Because the shape dia tidak begitu kuat untuk memegang di dalam position yang tetap. Okay, alright. So the next one is surface tension. Okay, tegangan permukaan. So it is the amount of energy required to stretch the surface of a liquid by unit area. Okay, dia merupakan tenaga yang diperlukan untuk stretch the surface of a liquid by a unit area. Jadi liquid molecules at the surface pulled downward and sideways, from the neighboring molecules, but not outward way from the surface. Tapi dia tak terlalu ke dalam lah, dari permukaan tu. So inner molecule experience the intermolecular forces in all directions by their neighboring molecules. Cuma dekat permukaan je, kiri, kanan dan juga di bawah. Ini. So dia punya position dia kiri, kanan dan ke bawah. Dia tak pergi ke atas dah. Tapi kalau untuk inner liquid, inner liquid molecules, dia akan experience intermolecular forces in all directions. So these intermolecular forces will pull the surface molecules into the liquid, causes them to stretch and tighten. Then the stronger the intermolecular forces, the higher the surface tension. So paperclip can float on water due to the high surface tension on water. Walaupun sebenarnya paperclip ni dia adalah besi, metal, and then dia lebih berat, tetapi dia still can float on the water surface of in a glass. Right. This is because dia ada surface tension. Right. Next is viscosity. Viscosity is resistance of liquid to flow. Kecenderungan untuk cecair mengalir. Jadi the greater the liquid's viscosity, the more slowly it moves. It flows. Jadi maksudnya dia terbalik lah. Bila viscosity lebih besar, pergerakan dia perlahan lah, sebab dia resist to flow. The stronger the intermolecular forces between the molecules, the larger the viscosity. Jadi semakin besar intermolecular forces, viscosity ni semakin tinggi. And these are the example of viscosity liquid such as ketchup, yogurt, and honey. Right. So example of low density liquid such as oil, our water, and a juice. Dia rendah untuk viscosity, kelikatan. Alright. So kalau untuk for a higher viscosity, it will take much longer time untuk fill up. So such as untuk masa yang sama for 20 second, water dia akan pergi up to 100 degrees 100 ml, and then for oil dia pergi bawah je, and then the honey yang paling rendah lah. Okay, after a time given, okay, 20 second di sini, dia punya larutan tu sikit je sebab dia higher viscosity. Compressibility, okay, keboleh mampatan. So compressibility is there is a very little empty space between the liquid molecules because the molecules are close to each other. So therefore liquid has low compressibility. Okay, liquid mempunyai compressibility yang sangat rendah. Jadi liquid boleh dimanfaatkan tapi dia rendah lah. Okay, for gas, okay, dia mempunyai higher compressibility. Okay, keboleh mampatan yang lebih tinggi. Next is diffusion. Diffusion is liquid diffused and mixed with other liquids. So diffusion rate of liquid is low because the liquid molecules are close to each other. Okay, sebab molekul liquid ni dia rapat di antara satu sama lain. And then it is also have a lower kinetic energy than gases. Okay, dia mempunyai tenaga kinetik yang rendah daripada gas. And then stronger intermolecular forces will slow their movement. So kita boleh tengok diffusion di sini, okay. An ink drop gradually dissolves into a glass water by diffusion, okay. So kita letak je, nanti dia akan berlaku diffusion, okay, resapan. Vaporization process, okay. Proses memasukkan menukar daripada liquid kepada vapor, okay. Surface liquid molecules have higher kinetic energy than inner molecule because it is surrounded by less number of molecules. At any temperature below boiling point, when the surface liquid molecules gain enough kinetic energy to overcome the intermolecular forces, it will leave the liquid surface as vapor. Okay, so gambar dia beginilah. Okay, bila dia mempunyai tenaga yang mencukupi untuk dia lepaskan daya di antara molekul. Okay, gas particle tu dia akan lari lah. Jadi dia keluar. So the particle with higher kinetic energy leaves the liquid surface. Okay, kalau liquid particles yang tiada energy, dia kurang lah untuk meresap. Alright, to vaporize. Then next one is the factor, okay, affecting vaporization rate. Okay, kadar vaporization. The first one is the surface area. Okay, the larger the surface area, the higher the chances for the molecules to escape from the surface. Okay, kalau surface area dia semakin besar, jadi kemungkinan dia untuk melepaskan diri dari permukaan tersebut akan lebih kuat. Okay, and then vaporization rate will also increase. Okay, kalau yang kedua kita tengok temperature. So as temperature increases, kinetic energy also increases. Okay. More molecules have enough kinetic energy to escape from the surface of the liquid, thus vaporization rate increase. Okay. Then next one is intermolecular forces. Okay, the weaker the intermolecular forces, the faster the vaporization rate. Okay, the next characteristic is condensation. When temperature is lower, okay, bila kita rendahkan suhu, kinetic energy of vapor molecules akan decrease. Dia akan berkurangan lah sebab bila suhu rendah, kinetic energy pun rendah. Vapor molecules become close to each other and form a stronger intermolecular forces. Kinetic energy of molecules can no longer overcome the intermolecular forces. Thus, vapor molecules turn into a liquid. Okay, so di sini kita ada liquid yang di bawah. Okay, so dia akan condensate. Okay, kita namakan yang di bawah tu adalah kawasan liquid, yang di tengah tu adalah gas. Jadi dia akan bergerak. Ada yang tinggal, ada yang akan bergerak. Okay, next kita tengok vapor pressure. So vapor pressure is defined as pressure exerted by molecules, vapor molecules at equilibrium with its liquid and closed container. So ini adalah definition untuk vapor pressure. Pressure yang dikenakan oleh molekul wap, okay, at equilibrium with its liquid and closed container. So molecule escape from the surface of a liquid referred as vapor molecules. In an open system, the vapor molecules will evaporate, okay, will evaporate off, okay, evaporate off will diffuse away. So untuk closed system, tadi untuk open system. So for closed system, vapor molecules which leaves the surface cannot escape from the system. Jadi bila dia tak boleh escape, okay, vapor molecules in a closed system, they remain in the container. Jadi dia duduk je dekat dalam container tu until it has a contact with the surface of the liquid. So these vapor molecules are in constant random motion. Okay, dia berada di dalam halaju mala, okay, constant random motion. Okay, so continually dia akan strike the wall of the container, dia akan melanggar dinding. So other vapor molecules pun dia akan strike juga. Jadi the surface of the liquid molecules pun akan dilanggar. Jadi every time the vapor molecules hit the wall of the container, pressure is exerted. Okay, pressure akan dikenakan. Okay, the next one is boiling process. Okay, we are almost done. So boiling process is the process of liquid change into gases. Okay, liquid bertukar kepada gas. Jadi ini dia terbalik dengan vaporization. Okay, right. And then the temperature increases. Okay, as temperature increases, the kinetic energy of liquid molecules also increase. So liquid molecules gain enough kinetic energy to overcome their intermolecular forces. Liquid molecules will turn into vapor. Okay, dia akan melepaskan diri dia sebagai wap air. Okay, next kita tengok boiling point. Definition for boiling point. Okay, boiling point is the temperature at which the vapor pressure of liquid is equal to the external atmospheric pressure. Okay, so boiling point dia merupakan suhu di mana tekanan wap adalah sama dengan tekanan atmosfera. Okay, it changes from liquid to gases occur at the surface and the inner part of the liquid. Okay, the bubbles are observed, okay, untuk boiling point. Jadi ada keluar bubble lah. Temperature remains constant during the boiling process, even heat is supplied. It is occur at specific temperature and pressure. Okay, boiling point dia ada suhu yang tetap. Tapi kalau evaporation, it can occur in any temperature. Okay. Difference between normal boiling point and boiling point. So untuk boiling point, the temperature at which the vapor pressure of liquid is external to is equal to the external atmospheric pressure. Kalau normal boiling point, dia merupakan temperature di mana vapor pressure of liquid is equal to the vapor pressure standard atmospheric pressure 1 atm. Okay, so kita tengok perbezaan di antara vaporization and liquid. So the difference between vaporization and boiling process. Okay, first one, vaporization process, okay, by which liquid changes to its vapor at the temperature below its boiling point. Kalau untuk boiling pula, dia adalah proses di mana liquid bertukar kepada wap, okay, as its boiling point. Okay, and then the second one is, okay, it takes place at all temperature. Kalau vaporization pada semua suhu. Tapi untuk boiling point, it only occurs at fixed temperature. Okay, alright. And then the temperature may changes during the vaporization. Jadi semasa vaporization tu, okay, kemungkinan temperature juga akan berubah. Okay, tapi kalau untuk boiling, temperature during boiling does not change. Jadi kalau kita letak 100 degree, 100 je. Okay, untuk boiling. And then it is slow and steady process. Dia merupakan proses yang perlahan. Okay, and then kalau untuk boiling, it is a fast and violent, okay, process. And then vaporization takes place only at surface liquid. Kalau boiling, dia akan take over the entire of the liquid. Okay, so the next one is boiling. Okay, boiling pula, vapor pressure dia sama dengan atmospheric pressure, so bubbles can form and rise. Okay, kalau untuk vaporization, vapor pressure is less than atmospheric pressure, so bubbles cannot form. That's why kita tak boleh nampak bubble dekat dalam vaporization. Tapi kalau untuk boiling point, we can see the boiling water. Okay, alright, so that's all for our video today. Thank you, class.